Hey there, once more welcome or welcome back depending how many of these modules in this AZ-2007 Accelerating Application Development using GitHub Copilot you've been watching so far. This specific module covers implementing code improvements. My name is Peter Detender and I'm a Microsoft technical trainer. My goal for this module is helping you understanding how GitHub Copilot can help you improving your day-to-day job as a developer, but also how it can help you improving the already existing code and code syntax that you already have, and just making it better from a code quality perspective. We're going to touch a little bit on reliability, optimizing the performance, overall improving code, you could say, and then also touching on some of the security capabilities. So 4 little tasks to go through. If you've been watching the full sequence of the course, this could feel like the last one, but I would say this module will still be more than valid because even if you missed any of the other modules, there's still going to be a lot of information that could be really beneficial for any developer, whether you're junior, mid-year experience, already super experienced, you've been a developer for many years, there's still, I would say, the need to continuously improve your code. And that's exactly what this module is about. Now, you already know the start of the module is where I like to tease your brain a little bit and writing some highlights down on the whiteboard related to this module. So I'm going to do the same for this one, where now the key question here is, what does improving code actually mean to you? If you ask me, one of the main things about code improvement is creating a standard based on what the company expects. Like reusing what you already have from former developing experiences, right? Avoiding bugs could be another good one. And if you have them, then obviously you're going to try and work towards fixing them. Making the app running faster is another one I'm picking up here. So that's where performance optimization comes in. Providing a better user experience. Integrating other services, like, for example, Key Vault. So you could have connection strings, secrets, passwords, secret information into your code, but I think we still have to warn developers to not do that anymore. So now an optimization could be to step away from that traditional hard coding secrets in code and moving it into a secret store like Key Vault on the Azure platform. Another one I'm hearing here is using latest frameworks. And most probably it goes hand in hand with using the latest packages. So I think in a nutshell, we have standards, optimizing performance, we have the better user experience, and working towards optimizing security. A lot of interesting keywords here on the whiteboard. So with that, I would say, join me in moving into the presentation. So let's jump in and touching a little bit on what are the requirements and then showing you a few sample prompts. And again, you can already assume that I'm going to walk you through just a couple of slides because it's not only fun and amazing to talk about capabilities, but I would also like to show you in a set of live demos. So what are some of the requirements when you think about implementing code improvements? Now, I would say it's a broad domain, right? So first of all, how do you get started? And not just getting started in improving your code, but getting started with embracing GitHub Copilot, bringing it into your development environment, and relying on the capabilities of generative AI thanks to GitHub Copilot and really helping you as, again, that assistant. So what do you need to get started? Obviously, you need to get a bit of feeling with using natural language out of that large language model that's so typical to generative AI, right? And knowing how it works. Remember, that's where you have GitHub Copilot embedded into your development environment. Visual Studio, VS Code, experience is almost the same. It's quite identical, no matter what development environment you're using. And next to that, you need to have some familiarity with using prompts. One of the really cool features that I personally like a lot about GitHub Copilot is the chat completion. It's going to approach using your natural language, which means you're going to ask questions, which now obviously with generative AI we call prompts, and you're going to use that to have that going back and forth conversation. Asking to explain code, asking to write code. We talked about unit tests in another module as well. And in this specific module, it's all about we already have code, the application is working, and now we want to improve it. Which again means code quality optimization, code reliability optimization, tuning, tweaking the performance of the app, and then also integrating a little bit on the security side. Now, zooming in on a few examples here, again, just a couple of slides. So the starting point of the slide is always, what are some of the factors that we should bring in to consider to investigate quality in this example? And then second, just a couple of sample prompts to really get you into that generative AI thinking mindset and how to integrate that mindset into your day-to-day job as a developer. Now, code quality overall refers to bringing in quality in your code base, which again could be making it easier to read. That's mainly helping not only yourself, but also helping your peers if they ever need to join the project, if maybe you need to go back into the code, but it's becoming somewhat legacy application over the next coming months, maybe years. It's always easier, I would say, to fall back to go through it if your code is a little bit more readable. It's the same for the maintenance of code. So one of the other aspects is maintainability of code. It's allowing you to make sure that not integrating bug fixes, actually integrating the fixes to the bugs that we have. That's where your maintenance window is going to become a lot more smaller, maybe a lot more efficient. And then obviously also touching on making code more modular, which means typically that you can reuse a lot of those modules across different parts of the same application, or why not across a lot of different applications that you're building, that your team is building. So to give you just a few sample prompts here on the slide, and I'll reuse some of these later on in the live demo, you could literally do it as easy as the first one here. Suggest me refactoring updates to enhance the modularity of a specific user class. Again, just an easy example. You don't literally have to reuse this prompt if it's not valid for your scenario. But if you think about how approachable it actually makes that technology, because in your brain, in your mindset, your goal is enhancing modularity of this specific user class, like adding some fields, some parameters, and obviously depending on what information you want to capture for that user. But now as a developer, you have to start thinking about what are, first of all, the building blocks that I need to really capture that user class. But next to that, now we're going to ask it to really help us optimizing, enhancing the modularity, splitting it up, moving some fields to some other classes, reusing the class naming conventions, and so on and so on. And again, just reusing that same natural language approach that you might already know from other generative AI solutions like ChatGPT, like Microsoft Copilot, maybe M365 or Copilot in Azure. It's now the exact same approach for GitHub Copilot. Write the question, yes, we call it a prompt, and start integrating it as natural as possible. Another example here is code reliability and performance. Making your code more solid. It's more reliable. We're going to optimize the performance. Obviously, it's not really a question about why should we do it. I'm pretty sure that all developers here can agree that there's always a good way to make your code more reliable. There's a good way to optimize the performance. It could be a cost impact. Like if your code is becoming more complex, it's not running as performant as it should be, it could mean, like, for example, in Azure or even on a virtual machine in your on-prem environment, you need to allocate more compute power to provide the same performance. Where now, if you from the development side can bring in better performance into your app, it could mean that you could move down to a smaller virtual machine size, maybe reducing the application service plan if you're running it in Azure. That would be the use case. And then second, optimizing again the reliability. So how to do that? You're going to validate, does my application actually meet functional requirements? And you can already imagine, start thinking about what are some of the functional requirements that we have not only within this application, not only within this code file, but what about the same requirements that we have across the board within the organization or within a specific application? We talked about some of these scenarios in other modules in this course, where GitHub Copilot is obviously starting from what it knows out of the large language model, but then also using syntax, using information, using snippets of code from already existing code base within your organization. And then reusing that information to make this specific app that we're now building more reliable, and integrating better performance. And then obviously another aspect from the performance optimization is providing a better user experience or a customer experience connecting to your application. Last example here in why is this reliability performance optimization so important? It's going to help you in avoiding or maybe faster remediation of potential issues. I mean, we all know as developers that any application, any code set will at some point have some issues. That's also why I would say a lot of developers actually love the job, because it's not that one-time shot like done, application is there, we delivered, it's running, and now we don't need to touch it anymore. There's always something changing within the organization, within the business, within the experience from the user that allows you as a developer to continue rebuilding the app, making it not only functionally better, but also adding more capabilities, adding more features, which typically also means every now and then, unfortunately, opening up the door for bringing in bugs, bringing in more errors. And obviously, we need to fix that. I wouldn't say we need to avoid that. Potentially, yes, we should. But out of being a developer for like 3 years, I would say I know more than good enough that that's not always possible to avoid them. There's an issue popping up. You're going to create a bug, you're going to fix it, you're going to release the new feature, and that's basically your bug fixing process. Obviously, next to that, it's all about testing. I'm not going to talk about testing that much anymore. Why not? Because we already had a dedicated module, how to integrate GitHub Copilot capabilities into the concept and complexity of unit testing. So if you're interested in learning more about that one, I would say please go back to one of the other modules, 100% deep dive focused on unit testing integration using GitHub Copilot. And then last here is exception handling. I mean, again, we all know that every now and then something can not only go wrong, it will go wrong when running your application. So what we're doing with exception handling is now trying to avoid the breaking of the application if something unexceptional happens. And it could be anything, right? So again, how does this map with using GitHub Copilot? So we touched on the technical, functional domains, potential issues, testing, exception handling. Going back to the good old natural language-based approach, interacting with generative AI, go back to GitHub Copilot, maybe rely on GitHub Copilot Chat, and just start using prompting. As easy as, can you suggest better error handling for my payment service class? Could be an easy example. Improve input validation in the login form to do something. That would be a viable prompt. And from there, again, GitHub Copilot is going to provide suggestions. You're still in control. You're the one who's in charge of accepting the suggestions, maybe going back and forth. Remember that chat completion experience, allowing you to ultimately come back to this is really the solution I'm asking for. You accept it, and it's getting merged into your already existing code set. Moving on here with some other last examples in optimizing reliability and performance. In a lot of cases, it's not just on the functional side, but now also on, I would say, the infrastructure side. A few examples we're touching on here is minimizing input-output like the I/O operations. Depending a bit how you write your code, obviously depending what your application is doing, it might have impact on like a database integration. Sending data through the wire, going back and forth, might not always be the most optimized. The same with like network optimization, network traffic, performance optimization. So a lot of that core infrastructure dependency is now also interacting with your application code. And obviously your task as a developer is trying to optimize it, like reducing the number of IOs, maybe even moving to multi-threading. It's another example here. Or why not just trying to avoid unnecessary computations? Like in the end, again, it comes down to running your environment, running your application more optimized, moving up the performance, making it more reliable, high available, reducing the cost for your backend infrastructure runtimes, where once more the way to do that is relying on sample prompts. An example here, can you, my dear GitHub Copilot, help me optimizing the sorting algorithm used in that product list in our sample application? Can you improve the efficiency of the search service? And again, so many other examples that you can bring in. Literally based on that easy language that you use, it's how your brain is thinking. And again, you're not really thinking or yet thinking in terms of how do I need to write that code optimization? Because that's again what GitHub Copilot suggestions are coming in for. Last here, and then we're going to switch to, again, a sequence of demos, is code security improvements. What does it mean, code security improvements? So first of all, you need to evaluate code security. GitHub, if you're a little bit familiar with the platform, is providing you code security optimization. Think about CodeQL, think about Dependabot, and that's scanning your code, and it's going to tell you like, well, you're using outdated packages. It's actually listing up any potential security risks out of using those outdated packages. But it also allows you to, for example, perform code reviews. It's again as easy as going into the prompts, using Copilot Chat completion, and it's going to allow you to literally use a prompt. I remember one of the examples in my case where you could go like, how should I optimize the security in my storing my user credentials? Where then from there, GitHub Copilot is looping through the existing code set you have for one specific part of your application, like a specific class or maybe a controller or anything else, looping through the code and providing you once more security optimization suggestions. It's up to you to modify them, going back and forth, having that conversation. And once you think you're happy, this is what you expect, this is what you need, you literally accept the suggestion and it's going to embed it, move that into your application code. Other examples, obviously, code vulnerabilities. Again, it's not 100% a core feature, a core capability of what GitHub Copilot gives you, but it's really embracing all other code security capabilities, which in the end you probably, hopefully, I would say you already have in your application code. But even if not, you could already get quite some information out of that. Hey, Copilot, can you emphasize, can you identify any of the code security improvements within a snippet of code, within a full application, what you call the workspace, right? And anything in between. So again, pretty powerful, really cool. Talking about cool, I'm going to say I talked for quite a little bit here, but it's so important to not only write good code, but really thinking about how you can improve your code that you already have, the code that you're still going to write. And again, once more, relying on GitHub Copilot. I'm going to stop talking for now. I'm going to switch for the last couple of demos to my demo environment. And remember, if you've been watching some of the other modules in this course, you know that you can just view the demos, Peter walking you through all the different steps. But even better, if you want to optimize your learning even more, you can actually go through the same sequence yourself by using that link that we talked about in the first module. So with that, let's jump into our last sequence of demos. So this module was all about optimizing code with a lot of variations, I would say. So again, I'm going to walk you through our last series of demos here. Now, up till now, if you've been following the sequence of the course, we've been primarily focusing on using that quarterly sales report application. So you could assume that we generated quite some sales. We had some pretty impressive numbers. Where now we're shifting to another little sample app, and that one is called I'll zoom in a little bit here for you, the AZ-2007 name of the course, Module 5 Bank Account. So what we're replicating here is just creating a little, again, console app just to make it easy. where it's acting as a financial institution. You know how it works. Money comes in, money goes out, and we're just going to run some validation. Now, since we're talking about optimizing code, it means that we already have an active working solution. It's been running fine for a few days, a few weeks, maybe a few months, or in best case, even a few years without touching it, right? For now, I'm going to just walk you through a few easy demos to show you how you can, again, rely on GitHub Copilot, primarily using the chat integration again, to show you just by running a few sample prompts, how you can start looping through your code and actually optimizing it. At the same time, I need to tell you that this is just an example where I'm just going to walk you through some of the sample prompts. Feel free to walk through the same scenario yourself using the same sample code from the GitHub repo, or maybe running the same prompts against your own applications. The challenge with improving code is that, and you'll find out in the way I'm walking through the demo, it's going from like a starting point. You're going to run a sample prompt. It's providing suggestions. And then based on those suggestions, you could run another please help me improving prompt. Again, getting some suggestions and continuously looping through. So instead of, I would say, I don't want to give you the wrong impression that you could now improve your code dramatically in just like 5 to 10 minutes demo, where in a reality, in a real life application, it would probably still take you multiple attempts, maybe even multiple days, maybe stretched over a few weeks to actually achieve the same. So just wanted to highlight to not give you the wrong impression, right? But I would say let's get started with manipulating some of our existing code. So it's a pretty traditional application. We have our main class up here, and what the main method, actually it's not a class, it's the method. What the main method is doing is the starting point, the entry point for the application, again simulating the banking system, and that's where we have the routines for creating the bank account and also using the accounts to do some banking, simulating transactions. Then we have a set of constants. So if I move down a little bit, we got a few other constants where the program is using a few different ones within our program class. So we have things like the number of accounts to create the number of transactions, and obviously transaction limits where we might run out of money. So from here, I'm going to open up my Copilot chat once more, and referring back to a few high-level keywords in the presentation itself, we would trigger literally that using our natural language prompt engineering. So since we're using the full bank account project, once more we're going to use add workspace, like use this environment within our Visual Studio Code. And I would say bringing you back into one of the first parts of the course, using GitHub Copilot to explain code. Now, we're not here to literally ask for, can you help me explaining code? But we're still using that explain keyword. Why? Because now we're moving into that one aspect of code improvement and, for example, using the readability. So I could do something that sounds like add workspace, use this Visual Studio Code environment, / explain. How could I improve the readability of the selected code? And I didn't select anything, but you already know from previous demos that it's using the current file. And we're going to manipulate that a little bit later on. So out of this pretty straightforward prompt, so please use this application that's currently open, and we're not changing code, we're just asking to explain, and then zooming in on one of the improvement aspects, improve readability. So it starts, I'll make it a little bit bigger again. So it starts here with an explanation. So in order to improve the readability, you could follow these steps. And that's what I meant at the start of the demo, where it's going to give me like a few suggestions for different things I could work on to improve that readability. And that's where it becomes like a never-ending story, right? So it's going to provide suggestions on how to improve code, reordering stuff, maybe making some changes to it. That's the idea. I'm not going to accept any changes for now because, again, it's just providing the suggestions. But I could do another sample prompt here where we're still using the add workspace. We're still using explain. And as you can see, it's recognizing the context there. This time I'm using the selection keyword, which we already used before as well. How could I, gonna move this on the side, how could I improve the maintainability of the application? There we go. Again, once more, just relying on your natural language. This is again what you would ask your colleague. Maybe you're a junior on the development team or a development specific application team, and you want to get up to speed. You want to maybe expand your comfort zone. You want to take charge of building some new updates inside your application. And again, so many other scenarios, right? Where now, instead of you digging in the code and maybe spending a couple of minutes, probably a couple of hours or days, it's nothing more than just running a prompt and asking for help. So now we're talking about maintainability, and as you could expect, it's going to provide us a nice description like, hey, this is what I, being GitHub Copilot, would recommend you to go through. Extracting methods, like breaking down larger methods into smaller ones, maybe creating the more modular approach, you could say. Encapsulating account creation, so moving that out from the main method into its own standalone method and doing about the same for some of the other ones. I could continue with similar sample prompts. I'm just going to pick out one last one here where I'm going to do add workspace. Let me, again, make it a bit bigger. Workspace, explain. And even here, I think the approach to do and write the prompt is actually becoming faster and faster and even more natural. How could I refactor, which is another code improvement, my code for better modularity? It was one of the previous suggestions, right? Where now I'm just going to zoom in a little bit more, relying on, again, some of the prompts. By using this approach, we can now technically do the same as before. It's providing suggestions on how to rewrite the code. And since we're already in that file, we could rely on one of those shortcut buttons, I call them. Inject code based on where my cursor is. Applying the changes, which means I'm going to keep the code that's not changing and overriding everything else, or doing the copy paste. Someone asked me like what's behind those little dots there that I didn't talk about yet, and that's where you have some other options like move that into the terminal or even creating a new file. So again, a lot of like low-level powerful ways to actually accept the changes and apply them. So I'm going to go for applying the changes. It's overriding some code, it's making changes, and then from here I could go into my terminal, waiting for the changes to get applied, running .NET build. I'm going to save you a couple of minutes here in our steps in the demo, but that's literally, I would say, the starting point of starting to improve your code using nothing more than GitHub Copilot Chat and using your natural language. So in this first part of the demo, it was about improving code, and I already showed you like about 5 sample prompts you could use to just get you a bit into that zone. How can I use GitHub Copilot Chat to help me improving my code? The next example here is another scenario that we touched on during the presentation, and it's improving the reliability and performance. We're still in our bank account sample application. Once more, feel free to follow along instead of just watching some of the demo steps here, where this time I'm using the reliability sample application. So you can see up here, I'm in a new folder in our sample apps, downloaded zip file, APL 2007 bank account reliability. I'm not going to explain anymore what this code is doing. You already know from the previous demo, it's a banking app account. We have obviously our account number, the balance, account holder name, account type, and so many other objects that we need to manipulate and simulate actually what a bank account scenario could look like. Now, when we talk about making your code more reliable, optimizing performance, there's again a whole set of scenarios that I think if I would ask like 10 of you, I would probably get 20 different answers. So some examples coming to mind is potential issues. The code is working, but like help me creating the try-catch looping scenario, you could say, in your development code. Or integrating testing. Now, we had just finished a dedicated module on testing, but it would also still help you improving the reliability and performance. Integrating optimizing algorithms was another example in the presentation. Optimizing, multi-threading, minimizing network latencies, optimizing storage interaction. I don't have them in this application, but imagine going back and forth across a database that's maybe running hybrid between like an Azure web frontend and a database backend. And again, so many different scenarios. So what's the catch here? It's going back to chat completion, where you're going to run a few prompts. And as always, it starts with workspace explain. And from here, using once more your natural language, can you help me improving exception handling? Can you help me reducing unexpected issues? Can you help me avoiding future bugs? And so on and so on. You can do this for the full application. You can attach specific code files into your prompts by drag and dropping them or adding them using the attachment file icon here. And again, so many different steps that would allow us to loop through all the different scenarios. So I'm just going to show you a few examples that I like. So I could do, how can I reduce unexpected issues for the selected code? It's going to loop through, and that's what I called the never-ending story in my previous demo part, where it's going to give you a starting point where in this case, and obviously specific to the sample app, to reduce unexpected issues in this banking account class, you could implement the following improvements. It's suggesting 5 of them. We need to work with custom exceptions, validating some input, thread safety, logging, unit testing, because again, we built unit testing, but that was in a different application. Well, now the next step is like, okay, can you help me with item number 1? So we could do literally that. Workspace explain. Can you share more? Make it a bit bigger. Can you share more specific details on how to improve the input validation as mentioned earlier in item 2? Which means up here, item 2 is what we have up here from the previous chat completion. Running that again. Well, now it's again looking into all the different files. It's looking into 3 different references, the main console application, the bank account method, and classes, and some of the exceptions. So now we're starting again from a pretty high-level scenario, the first chat prompt we used, and then from there gradually moving down. Well, now you could actually repeat the same thing, because for this specific item, it's now coming back like, well, I got 3 different suggestions. You need to work a little bit on your credit part of the application. You need to work on the debit part, and you need to work on the transfer part, like literally the 3 main components in the application. So now I could do the same, where I continue my conversation at workspace, explain, and then again using natural language, zooming in on the check for sufficient balance. Can you suggest code changes? What we're doing now is starting or continuing actually the conversation based on item number 2 here. Looping in our source files, looping through the different code scenarios, and again, gradually providing the step-by-step instructions, where now again, once more, I could accept this. I could do like, okay, replace, apply my code. And from there, again, it's doing the same process that we showed you for the reliability, but this time for performance optimization. And again, there's so many other steps you could go through, all depending on your application. That would be the main thing. Now imagine that I obviously showed you how to start from the high level, but now you go like, well, this is what I did on day 1, where now it's day 2, and I know that I only need to finalize my debit component. Or let's say the credit, because I think we just finished our debit part. So I'm in the selection here. I'm going to do Control I, like our inline call to Copilot, where now I could do, can you help me rewriting code to validate input for this selection. And it's actually coming back with a pretty nice suggestion here, where it's going to throw new argument exception, like credit amount must be positive. So that's, again, literally how easy it can be. And you can see the experience is about the same. I'll make it a little bit bigger. So for the bank account, it provided a suggestion here from the higher level project-based approach, throwing a new argument exception with, again, some other code validation. Where now, if you don't want to use the full method or you don't want to use the full project approach, you could still use the inline chat experience for a subset of code. By the way, and that's actually also pretty nice, we talked about this in our first module, getting started with GitHub Copilot. So right now in all demos that I did, we're using the GPT-4o, the latest model coming from OpenAI, but if you want, you could actually play with some of the other ones. In my case, they're in preview, so I'm not going to try and change my code. But remember that based on your GitHub Copilot licenses, you could actually manipulate what kind of large language models are getting used for the code suggestions, the explanations, the documentation, and all the other features that we talked about. And you're not stuck to them like, oh, for this app, I can only use one model. If you are not all that happy with the suggestions, you could maybe try and switch to a different large language model. And then from there, maybe validating if there are some important changes happening just by switching that language model. So with that, we're basically at the end of our second part of this demo. So that we're at the end of this module, where it was all about code improvements using GitHub Copilot Chat. And then talking about what do you mean by improvements, we touched on optimizing overall code quality, optimizing code reliability, code performance, and obviously at the same time, application reliability and performance. And then last, touching on some of the security integration optimization capabilities, all that thanks to GitHub Copilot Chat. Now, apart from being at the end of this module, we're also at the end of this full learning path. If you've been here with me throughout the whole sequence of the course AZ-2007, we covered a lot. Why? Because we started with getting started, setting the scene on what is generative AI, how does it link to GitHub Copilot, and what does it mean to really bring in GitHub Copilot features into our day-to-day job as a developer, using Microsoft Visual Studio VS Code as your development environment. From there, we switched to specific development tasks, where the next module covered using GitHub Copilot to explain code, to help you documenting code, using traditional GitHub Copilot capabilities, but also relying on GitHub Copilot Chat. In another module, we covered really, I would say, the core of what it takes to be a developer, and that's really writing code. Where now, thanks to GitHub Copilot, it allows you to you rely on developing code thanks to code completion. You start writing a small sentence, a little bit of an explanation, and it's providing you code snippets, right? Another module we had was, I would say, one of the harder ones for me as a developer. It's writing unit tests, but not only writing them, but also understanding how to create them. Starting small with pretty basic unit tests, already adopting the unit test approach that you might be familiar with outside of using GitHub Copilot, like XUnit and Unit, like the traditional unit frameworks, and then again integrating capabilities from GitHub Copilot to help you optimizing writing tests, starting small all the way to creating that full end-to-end unit testing project. And then in the last module, it was already covering everything we touched on in previous modules, but now taking it to the next step and really improving code quality, code security, code reliability, and code performance. I'm done for helping you understanding the capabilities, how amazing GitHub Copilot is in your day-to-day job as a developer and or DevOps engineer. I hope you enjoyed as much as I did presenting this course, but on your side, learning about GitHub Copilot. You enjoyed watching the demos, and I would say, please continue your own learning journey. That's why we have this link on the slide, where you can go through our Microsoft Learn platform, reading through the different modules in your own time. And from there, I would say, start loving GitHub Copilot as much as I do. My name was Peter Detender. I'm a Microsoft Technical Trainer at Microsoft. Hope to see you again in one of the other courses that we have. Thank you for now, and see you back soon.